So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveri Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware, so my subject is physics. We are in class 7th. Today we are going to start a new chapter, that is chapter number 2, Kinematics. We are at the session number 1. So we have finished with the chapter number 1, units and measurements in the last class. Now today we are entering into a new chapter, Kinematics. So before going to directly to the chapter, let us recall what we learned about kinematics in the lower classes. You recall into your last class. So before going for textbook, let me. So in physics, so when you take the physics, which is study of two parts. One is the 50% part is mechanics and other one is energy. Study about the energies, right? So entire physics is studied under two headings. One is 50% part is mechanics part and remaining 50% is study of the energies. So when you go for energies, you can find so many chapters like sound is energy, heat, light, right, and magnetism, magnet, electricity is also energy only, electronics is also energy only, right? All the study about all these things comes under physics only, right? So we'll study about the sound, light, heat, magnet, electricity, electronics. All this comes under one part of the physics. Whereas the second part is very important. So this mechanics is classified again three parts. One is kinetics and the second one is kinematics, which we are discussing today. And third one is dynamics, right? So entire mechanical part is studied under a different headings of kinetics. So kinetics is nothing but study about the rest of a body. Rest. When a body is in rest, what are the conditions? At what conditions, under what condition body be at rest? So kinematics is study about the motion. Here, no cause. We are not discussing about the cause of the motion. Why body is moving, we are not discussing. Only you are discussing about the motion of the bodies and various types of motions and what are the terms come across when body is in motion. Whereas dynamics is study about the motion only, but with cause. We'll study about the cause here. That is force. Cause is what? Force is the cause of motion. So force, Newton's laws of motions, everything comes under dynamics. Like that, entire mechanics will study under the three different headings. Okay, in the kinematics again, solids different, liquids different, gases different, dynamics also difference for everything. So it's a complete picture of the physics. Where we are today, we are going to start a new chapter named kinematics. So kinematics is a branch of physics or branch of mechanics which deals with the motion of a body without cause of motion. We are not at all discuss about the why body is moving. We'll simply discuss about whether body is moving or not. If it is moving, what kind of terms will come across? When a body is moving, it contains distance, displacement, speed, velocity, time, acceleration, retardation, all these. After knowing about all these terms, what is the relation among these terms? This relation among these terms gives some equations, some formulas, which are called equations of motion. Up to that, we have discussed the chapter. It may take 3 to 4 sessions. Okay? Clear? Now we'll move to the today's topic. Roughly, you can take this tree, very important. You can note on your notebook, top physics, right? So if you want, you can write the definition of physics also. Physics is study about the matter and energies. Matter and energies, different types of energies. Study about the matter and different forms of energies is called. Then mechanics is study about the motion. Again, in the motion, one is at rest. Study about rest is called kinetics. Study about motion without cause is called kinematics. Motion with cause. Cause is nothing but force. Is called dynamics. And second part is energies like sound, heat. All these chapters will come across in physics only. Right? Just take note as it is. Something happened here. I want. I know why this is. Okay, now we'll move to the our chapter, right? When you move to the chapter here, third chapter number 3, chapter number 2, sorry, kinematics. Just a minute, let me close this. Something wrong happened here. Let me. Okay. So you can see the second chapter here clearly. What is okay? Just let me stop sharing. Again, I'll share. So whenever right. Anyway, there is some problem with this. Okay. So so we'll start the chapter after basic introduction. We'll start the kinematics, the chapter number 2. So already I discussed what is kinematics. Again here, mechanics is the branch of physics which deals with the motion of the bodies. Kinematics is one of the branches of mechanics. It deals with the motion of the bodies without considering cause of motion. Without considering cause of motion. We are not discussing about why body is in motion. No, no way. That will go to next branch. So, right now, first we'll discuss what is rest. When a body does not change its position with respect to surrounding of a body is said to be at rest. A chair lying on room is at rest, state of rest, because it does not change its position with respect to surroundings of the room. Suppose your tables are there in classroom. In classroom, your tables are there. After the end of the school, you'll go outside, go home. Tomorrow morning, you'll come back to school. Your tables are there only. Or your teacher chair is there only. What is the meaning? They are not changed their position. They are remains at one place, then they are said to be at rest. Any body, if it remains at the same position for a long time, suppose I am sitting here, even though I am teaching lesson for you, I am not moving from chair. So I am at rest only, as per physics. As per physics, I am at rest. Even though I am doing work, I am taking the class for you, I am working with the every other parts. But as I am not moving from here, I am at rest. Means body is not moving, you can consider as a body is at rest, right? Next, motion you can see here. Motion. What is motion? When a body changes the position. Suppose your classroom chair is there, one chair for teacher. So it is on the dais for some time. So teacher while moving, she asked to bring the chair to back side, back of the classroom. Some of you go and move the chair to back of the classroom. So what is that meaning? That meaning is the body, the chair changes the position. When the body changes the position, we can call it as motion. So a common characteristics of all moving bodies is that they change their position with time. For example, now it is 11 o'clock. For 11 o'clock, you are sitting in the classroom. At 11:30, you go back to your class, other classroom. Now you are in the digital class. You go to the classroom. So you are in motion. When you change your position, whenever our next class will come at 2 o'clock, again you come back to the digital class. Like that, you are moving from one place to another place for attending the classes. That is changing the position. When a body changes the position with respect to time and surroundings, the body is said to be in motion. Right? So rest is not changing the position. Motion is changing the position. Simple. Right? So both are interchange only. There is not separate terms. When a body is at rest, it is not in motion. When body is in motion, it is not in rest. That is they are called relative terms. Both motion and a body are relative terms because they are connected to one another. They are related to one another. See here. A common, the rest and motion are relative. An object at rest with respect to an observer may not be at rest with respect to another observer. Suppose your friend is here, right? You are here, and one object is here. Say some car is here, right? So you are observing that car as well as this fellow is observing. Or suppose you are observing a person sitting on the car. So if you observe this car, it is moving from you. You feel that this is in motion. But the person sitting in the car will feel that you are in motion. That is relative, one with other. So depends on the surroundings. We can decide whether body is at rest or motion. That's why they are called to be a relative motion. What is relative to each other? Both the terms motion and rest are relative. Right? Clear? So this is the first basic part of the kinematics. Motion. What is motion? What is rest? Now come to the different kinds of motions. So in our day-to-day life, from when you wake up from the morning to till the go to the bed, we'll see so many types of motions. So morning, suppose your mother will start your grinder, mixture grinder for grinding something. So in grinder, take some kind of motion. So when you open the tap of water in the bucket, you can observe the water carefully, find some kind of motion in the water molecules. So when you start your cycle to go to school or vehicle to go to school, you can see the motion of the vehicle in one direction and tires also moves in some new kind of motion. So there are two kinds of motions there. So you are walking after getting down from the gate of the school, you will walk to the classroom, and that is also one kind of motion because you are changing the position. So every movement of you will give us some kind of motion. Suppose if you see some mosquitoes are moving here and there, that is also one kind of motion. When so many vehicles are moving on the road, straight line or curved path, or circular motion. All these are the kinds of motions only. Any body, if it changes the position with the time, it is considered as a motion. Right? So we are to discuss here, we are going to discuss about the different kinds of motions which will come across in our day-to-day life. See, you can see first one, translatory motion is the one kind of first kind of motion, translatory motion. Right? Translatory. The motion in which all the particles of the body moves through same distance at same time, called translatory motion. Example, you see, a bus moving on a road, the motion of a rising balloon, the free fall stone under the gravity. See, a body moving along the road, all the parts of the body, car, bus, a bus moving, bus, all parts will move in same direction, all reach to the same destination. One tire will go to Drishonagar, one tire want to go to Koti, or one tire will go to Nampalli. Not like that happens. All the parts of the body, all the particles of the bus move same direction and they reach the same destination. Such kind of motion is called translatory motion. The motion of the raising balloon. When balloon is allowed to raise, gas balloon, entire balloon will go to the air. Not some part of the balloon one side, some part other side. Right? Suppose when you drop, suppose I am dropping a pen. Entire pen is coming down with the influence of the gravity. It won't become the parts. All these are called translatory motions. Clear? So all the particles of the body moving in the same direction for same time. Suppose you are firing the bullet. The bullet will go in same direction and hit the target. Entire part of the bullet. Arrow with the bow. It will go, all the arrow will go and hit the target. All these are comes under translatory motion. So in this translatory motion, again, there are two types are there. Whether the body is moving in a straight line or whether the body is following the curved path. If all the particles of the body moves in straight line in a given time, that is called rectilinear translatory motion. Right? Rectilinear translatory motion. If your body is following curved path, suppose as long as car is going in a straight line, the motion of the car is rectilinear translatory. When a body sudden turn came, when a body is taking turn, that is called curvilinear translatory motion. So when an object moves along straight path, its motion is said to be rectilinear motion. The marching of the soldiers on straight road, marching. The motion of the car in a straight road. The motion of the carom board coin are examples of rectilinear motion. When an object moves along curved path, turning motion, suddenly you have to turn. Its motion is curvilinear. A bus moving in a flyover bridge. A car taking a turn. A football kicked from the ground into the air. All these are comes under curvilinear motion. So these all are, no doubt, they are translatory motions. In the translation, again, two categories. If the translatory motion takes place in straight line, that is called rectilinear motion. If the translatory motion takes place curved path, it is called curvilinear motion. Right? So this is the first kind of motion where all the particles of the body moves along the same direction for same time. Okay? With so many examples. Now come to the second type. Rotatory motion. Rotatory. So you can see the so many examples for this. The motion of object rotates above a fixed axis or a fixed point is called rotatory motion. The motion of the body, blades of the ceiling fan. Ceiling fan will move fixed point, it won't move here and there. At fixed point, moves around the blades will move. Called rotatory motion. The motion of the blades of ceiling fan. The spinning motion of the top, you can see here. Top, this is the top. So top will move, at same position, move around it. The motion of the turbine. Turbine. Even you can see in the washing machine also formation of turbine. All the clothes will move. The motion of the earth around the sun, all comes under rotatory motion. Examples you can see. The wheel of the moving vehicle, wheel. Vehicle will go rectilinear, but wheel will go rotatory. In some cases, the rotatory and translatory motions takes place simultaneously. When a bicycle moves, its wheels undergoes translatory and rotatory motion. Because wheels will go straight line only, they also move circular. Both can be seen at one place. Okay, this is the second kind of motion called rotatory motion. What? Rotatory motion. Clear? Now, third type of motion. Oscillatory motion. Oscillatory. To and fro. See, to and fro motion of the body is called oscillatory. If you see watch at home, olden days watch, clock watch, there is a pendulum will be there. It moves here and there like this. When the pendulum keep moving, the time will change. That is to and fro. Suppose sewing machine, cloth stitching machine, the needle will go up and down like this. That is a up and down, to and fro. All this comes under oscillatory motion. Even swing. When you sit on the swing and swing like this, it will go to and fro. That is oscillatory. The motion of the pendulum of the clock, the motion of the needle of sewing machine, the motion of the piston of the engine. In engine, there is a piston will be there. As the vehicle moves, it moves up and down and makes the piston to move smoothly. Right? Are the examples of rotatory motion. A metallic wire fixed at the end and plucked start moving up and down. Suppose veena, guitar, or any, when you see the stringed instrument, when you plug the string, what happens? The string will vibrate up and down and get the sound for us. So that is the vibration comes under oscillatory motion. It is also called as vibratory. Okay. This type of motion is called vibratory motion. In the stringed instruments such as guitar, veena, violins, the motion is vibratory. The motion of the membrane of drums you can, the leather part is there, that is called membrane, layer. When you hit that layer, it will vibrate and gives a sound. Because for producing sound, vibration is important. Drum also called vibratory motion. It must be noted, during the vibration motion, the change of size and shape may take place. So the pendulum of wall clock, the swing of cradles, all comes under the oscillatory or vibratory motion. Both are same only. Up and down, to and fro, right? All these motions comes under oscillatory motion or vibratory motion. So next comes periodic motion. Periodic means continuous. A motion that repeats itself at a regular interval of times. Continuously body is moving. For example, Earth is moving around the sun from so many millions of years. Same speed, right? Almost 365 days will take 1 year. Next 365. There won't be any change there. Because repeatedly moving around the same path, same orbit, right? That is called periodic. Periodic means continuous. When you are doing any work for same time continuously, that is called periodic motion. So example given, only example, Earth around the sun is the best example. Clear? Random motion. Random is nothing but irregular. Irregular. For example, mosquitoes are there. When the mosquitoes are moving in the room, how they move? Is there any direct particular path for them? No. They move here and there regularly. Irregular motion, changing the nature of motion frequently, is called random motion. Motion of the fish in the water. Motion of the mosquitoes. All this comes under the random motion, or it is also called as irregular motion. The fifth type of motion. Clear? Random or irregular motion. So when you move forward, last type of motion, circular motion. Suppose you tie one stone to the thread and move it. Whirling. It is called whirling. When a stone is whirled, the path followed is circular. So many ways you can see. For example, when you go to circus or exhibition, you are climbing on the giant wheel. So the motion of the giant wheel also comes under circular motion. So is a special case of rotatory motion. Is also rotatory motion only. A special case. in which the distance from the axis of rotation is always fixed. Radius is constant. See, the radius is always constant in the circular motion. That's why it's come as circle, where a special type of rotatory motion where the distance from the axis of the rotation is always constant. Each particle of the body executes rotatory motion, right? So many examples you can write for the circular motion. These are the 6 major types of motions which will come across in our day-to-day life, right? So before going for the further, let me show you one video on these types of motions. Then we'll move to the next part. Okay. First 2 parts we'll see here.
Motion. An object is said to be at rest if it does not change its position with respect to its surroundings with the passage of time. For example, a school bag lying on the table does not change its position until disturbed by somebody. Thus, they are considered to be in a state of rest. An object is said to be in motion if it changes its position with respect to its surroundings with the passage of time. For example, a moving car and children playing football change their position with respect to their surroundings fixed point. Thus, they are considered to be in a state of motion. Rest and motion are relative terms. Imagine yourself sitting in a moving car and looking outside. You will observe that your position is changing with respect to the trees, the lamp posts, etc. However, your position is not changing with respect to another person sitting in the same car. Hence, we can say that rest and motion are relative terms.
Here.
Motion in a straight line or linear motion. If the path of a moving body or object is a straight line, such a motion is known as a linear motion. For example, if a boy starts moving from position A and passes through positions B and C to arrive at D as shown. Since the path from A to D is a straight line, the motion of the boy is said to be straight line or linear.
That is rectilinear.
Types of motion. The motion of an object in a straight line is called linear motion. For example, motion of a free-falling ball from a height. The motion of an object revolving around a fixed point is called circular motion. For example, motion of a blade of a table fan. The motion of an object completing one revolution in certain time interval is called periodic motion. For example, motion of hand of a clock. When any object executes repetitive motion with respect to a fixed point, then it is called an oscillatory motion. For example, motion of a pendulum. When object executes random motion, it is called random motion. For example, motion of flying butterfly. Distance and displacement.
So this will come across in
Ali
each class.
wants to read.
So this is our next topic. Whenever body is in motion, when every moving body will have distance, displacement and all, that we discuss in the next class. Right. So what we discussed today is what is rest, what is motion, and what are the various types of motion, 6 types of motions with complete examples. Right. See, the movement of the moon around the earth is repeated for every 30 days. And this motion, that is called dash motion. So as it is compulsory, 30 days we do it, called as a periodic motion. Like that you can answer easily directly. When you are perfect in understanding the concept, you can answer any question. This is a periodic. Rest and motion are relative. So when a body moves in a straight line, it is a rectilinear motion. Curvilineous turning, all these are different only. Any motion repeats itself regular interval of times, again periodic motion. Earth around the sun. Oscillation of simple pendulum is called. Simple pendulum is called. It's not this one. This is not this one. Non-periodic or periodic. Same periodic because pendulum moves around the same direction. When a body occupies different positions at different instant of time with respect to frame, then body is called in motion. So like that, when you understood the concept in a simple way, you can answer the any question. It's all only conceptual. So if you have any query, we have provided you complete solutions also for all the levels. You can first attempt from your side, then check with the first all you tick your own answers after understanding the concept. So what we say, just two concepts completed. What is motion? What are the types of motions? Based on that, if you understand all the 6 types of motions and the concept of motion, you can answer all these questions easily. Motion of the housefly is an example of what is housefly? So random. It won't go in particular direction. It move here and there. Makes so much noise in your ears. That is a random motion. The random. Right? So rather easily you can identify the types of motions. With this, you can make one project also. You do one project. Already we given in the science adda also. So identifying the types of motion last week. So that is part of your regular syllabus, IIT syllabus. Okay. So just mention the types of motions and give the examples and paste the wonderful colorful photos you can get from either your material or from the Google. So that makes as a project week for you. Whenever this topic we are attending the examinations, you make the project as motions and types of motion. Okay. See, so many are the all these things comes under the same. Right? See, mathematics also given examples of different types of motion, swinging of cradle, spinning of top. Just now we have seen already examples. Motion of the fishes in the water, random. Car moving in a straight line, rectilinear. You can match directly. Sometimes one case can have two motions also. Then next we'll discuss in the next class, we'll discuss about what are the terminology we'll come across when body is in motion. Very important. Distance, displacement, speed, velocity, acceleration, retardation, time. After discussing about all these things, what is the relationship among all these? That will use some mathematical formulas for the us, where we can have lot of chapters will deal with that formulas, right? So that's all for today. So that's all for today. What we learned about the kinematics for the second chapter of the class. So we'll continue in the next class. So thank you, students. Have a wonderful day. Thank you.